We're live, I hope. Yeah, I think we are. Okay. So welcome to another Monday Night CAD. Almost forgot how to say it. And today we're going to continue working on the Lure Turner project. I think this is going to be the final Lure Turner live stream before we actually assemble the thing. And I'm thinking of maybe doing a live stream to assemble it. So assemble it live midweek. We'll see. But I'm still missing a part, so hopefully that will come soon. I don't know what's wrong with shipping, but should be here soon. Anyways, I actually was doing some CAD work today, and this piece right here, which is fully parametric by the way, is for my what was it called? Honeycomb storage wall, which is looking nice. This one is for the screws. I'm also doing another one for some other stuff. Maybe I'll plug it here. And yeah, I assembled my my wall in the wrong orientation. That's why I'm designing my own stuff. Anyways, let's open. Where was it? FreeCAD. Lure Turner. Lure Turner. Was it the V2? 5. Oh yeah, it was the V2. Yep, that's the one. That is the one. Okay. So we need to do the final touches before I actually print it. And I think the only thing that we need to implement is the mounting holes for the power supply. The fan is done, that's good. And this part right here, the board. Yeah, I think that's all. Did I miss anything? I hope not. Oh, and by the way, I got the correct springs. So I have the correct springs now, which is nice. Okay. Yeah, let's start with the power supply. Let's see. I have it here somewhere. You would think that I have prepared it, but no. And I don't know what happened to the music. This is supposed to autoplay. So here's the power supply. It's a cute little power supply. I think we can even get a smaller one. But it has 2 holes. And these are, I should also bring my calipers. Give me a second. Okay, so we need to take a couple of measurements. First of all, I want to check if this is an M3. No, oh. It's M2. Is it? Let me quickly get an M3 bolt. It's weird if it's M2. Hopefully it is M3. Let's see. Oh yeah. Yeah, it's M3. It's M3, but there's barely any room for the nut, for the screw. Now this is a, I think we only need 2 mils, 2 or 3 mils, and then it will hit something, which is a very weird design. I hope this is how it's supposed to be done. There are also 2 screws on this side. Huh. Should we mount it on this side or the other side? But I think we have the same issue even on this side. I don't know if you can see. It barely goes in and then it touches something. Anyways, let's assume that we only have like 2 or 3 mils. This is an M3 by 16. And what is this thickness of the wall? Let's see. That's not too thick. Probably measure it. You can check it also on the spreadsheet. That's 4 mil. Yeah, that's bad. We need some spacers, which is probably a good idea anyways, because this can get hot, I guess. Okay, so let's hide everything that we don't need. Bearing, we don't need that, we don't need this, we need the box, we need the power supply. Let's hide the fan, motor, screw, wherever. Okay. So the problem is, the screw is 60 mil. And we only have 4 mils in here, and we barely have any room inside the power supply, so we need some spacers. So the power supply placement at the moment on the x-axis. First of all, where's the fasteners? Screw length, I have it at 10. This is actually 16. I hope this will not break anything. We'll check the other models in a bit. So we have the screw length, screw and depth, screw and diameter. I don't remember what these are, I'll check them later. But for now, we need to make sure we have enough space between the power supply and the electronic box. So in the x-axis, what do we have here? We have the thickness, and I have the box width. Okay, so let's add to this. How much do we want to add to it? Or let's define something. Electronic box params, power supply. Let's do a power supply spacer length. So what is the length of the power supply spacer? We have 4 mil in thickness, so that's going to be equal to fasteners dot screw length minus thickness minus thickness. So now we have, let's say we're at 16. If we remove 4, let's leave 2 mils. Is 2 mil enough? I think I'm gonna leave 3 mil. So this is the spacer length. And we need to add 2 spacers here. Now, where do we need to add these spacers? We have the holes here. I want this to be mounted like this. So the distance here between these two is 52. Yeah, 52 mil. So let's add a row here. It's below power supply distance between screws is 52. And the spacer length is 9. And we need one more thing. Power supply screw offset from top. And this is basically the position of the first screw. So what we need this to be is it's 10 mil to the beginning. I think it's even less, it's about 9. It's 9 mil to the beginning of the screw. But, so this is actually 9 plus fasteners dot screw diameter divided by 2. That's the actual value, 10.5. Oh, whoops, what did I do? But it doesn't make sense to be 10.5, maybe. It should be 10. It flexes a bit. Yeah. There's a bit of flex in it. So I'm gonna leave it. Nah. Let's make it 11. I'm not gonna make it. Yeah, because if we move it down, that's better than moving it up. So if we missed by a millimeter down, that's actually good. We're offsetting it from the top. So I think we have everything we need to start actually modeling. So we have the spacer length. So let's start by doing the spacer. So first I'm gonna take the power supply and let's remove the spacer length. Oh, whoops. We need to add. Because it's negative. Yeah. So now we need to model 2 spacers, one here and one down here. Now the only problem is, wait, do you offset? distance between screws is 52, but this is the distance between the beginning of the first screw to the beginning of the second one. So we need to add fasteners dot screw diameter. Yeah. So that's an equal here. 55. That's the actual distance between the two centers. Okay, cool. Electronic box, let's make it active. Do we have any datum planes I can use? No. Huh. Yeah, we can do something here. We can attach a datum plane to this one and then move it by electronic box dot thickness. Cool. So let's create a sketch. I'm gonna look at it from the back. Is this from the back? Yeah. So it's gonna be something like this. These two are equal. They are also on the same vertical line. And Matthias, how are you? It seems to be a bit of an echo in the audio. Interesting. Let me check something. Oh, what's going on here? Sorry about that. I might have like disconnected and reconnected my mic, so it changed the graph. Now it should be fixed. Thank you, Matthias, for how do you say this? Notifying me about the issue. So yeah, basically what I'm doing right now, in case you just joined, is I'm offsetting the power supply by a specific distance, and then I'm gonna create a spacer. Now the reason for that is because I have M3 by 16 screws. I don't have any smaller M3 screws. But later, let's say if I bring M3 by 10, it's easy to fix. I just change this value and it should update the spacer also. So now I'm adding these spacers to hold the power supply. There are 2 screws on the back that we need to implement here in a bit. That is better. Great. Okay, so the diameter of these will be, I guess we can also define that. But I don't think we have to. At some point it becomes just overdoing it. So all we need is the screw diameter, and then let's add 3 mils on each side, so that's 6. This should be strong enough that it will not break and it will hold the weight of the power supply. And we also have the distance here, and this is the power supply distance between screws, and we have the distance from the top. So now we need to center this, and we also need to offset it from the top. So first let's center it. So from here to here, this should be. Is it width? No. No, it's general dot width divided by 2 minus the electronic box params dot power supply width. I'm trying to remember. It's been a while. Also divided by 2, and I think there's a tolerance. No. Oh wait, no. So he's. Yeah, it should. Wait. So if we come here, that's the width divided by 2. Then remove thickness. Oh, did I remove thickness? Yeah, that's the problem. I didn't. Oh, come on. FreeCAD just hates me. Thickness. No autocomplete, please. Okay, now it's in the center. So now we just need to define the offset from the top. This also should be easy. So the vertical distance is general.height minus also electronic box params.thickness, and also a tolerance from the top. And we have the offset, power supply offset, power supply screw offset from top. Cool. I think we could have also made them symmetric to the center line of power supply, but anyways. Now we need to extrude this, so we need to pad it by power supply oh, there's a typo here. That's fine. Spacer. So now we have a spacer. Now we need the actual M3 hole. So unfortunately we have to redo it. So where is it? Pad. One thing we can do, we'll try to do, is copying the sketch, and I haven't tried it. Okay, we can use this datum plane. I haven't tried it in a parametric workflow, so let's see if it works. Let's hide the plane again. We don't need it. So it's called carbon copy, I think. Where is it? It should be somewhere here. And the tools, no. Leave sketch. Create a carbon copy, here is it. So if we click this and then click this sketch, it will copy that sketch here with the so it's getting the constraints from sketch 59. Yeah, that's the problem with FreeCAD. And that's the reason I don't, for example, click fillet and select one of the edges, because the way FreeCAD works at the moment is everything has a number. Like, for example, this constraint. It's constraint number 2 from sketch 59. So if I later edited sketch 59 and changed some of the constraints, the numbers will change, and then this will break, because it will go to sketch 59, give me constraint number 2, but constraint number 2 could mean something else later, or it couldn't even exist. So that's the issue with FreeCAD at the moment. They are trying to fix this, but for now, I have to redo stuff. So let's get this from fasteners.screw diameter. And what else do we have? Do we have tolerance? What is this tolerance? Okay. But I don't think... No, I think this tolerance is for the nuts because it doesn't make sense here. Let's just use the general tolerance. 3.4, cool, this should be fine. These two are equal. One thing I'll need to check, these constraints are here, right? Yeah. So these are fine. The only issue is this. Let's reference the actual value. Power supply, distance between screws. And we need to redo that. So general dot height. Thickness. Tolerance. And what else? What was it? Minus electronic box dot. That's not a minus. It was offset from top. Cool. This one is fixed. This one is fixed. This one is not. So it was general dot width divided by 2 minus electronic box params dot thickness minus general dot tolerance minus electronic box params dot width power supply width divided by 2. And where's the typo? Where's the typo? Okay, here it is. Nice. So we need to pocket this by in the reverse direction. Let's go. Can I do through all? I think yeah. Yeah, because there's nothing here to break it, so we're fine. Okay. Now we can for example select this and create a countersunk edge right here. I think it's 1.6 for my screws, but the problem is we selected an edge, so we have a problem. The boring way of doing it, but it will work 100%, is redoing the exact same sketch with a bigger circle, then doing another sketch down here with a smaller circle, and then doing a loft. This way it's 100% parametric. But yeah, it's it's gonna take some time. Okay, so this is fine. This one right here, I think is no longer relevant. Or is it? Wait, sorry. No, I think it is relevant, but the only problem with it is the inlet, the power inlet, is gonna be protruding a bit outwards. There is no groove for it to sit in, which I think is fine for now. I will fix all of these when I actually am ready to print. But let me see, did they provide... Because I don't have this. This is the model, or not the model. This is the part that I don't have at the moment. I have the power supply, I have the fans, I have everything. So technically I can assemble this and try it even without this, but I would rather wait till I have everything, and I'm working on other stuff at the same time, so that's fine. Where is my orders? Yeah. So do we have the thickness? What is this? 20? No. 27. Okay, what's this thickness right here? Oh, it's here. Okay. So we have the thickness. We can probably draw it. So I can save this. We can, what I'm thinking is if we can import this image into FreeCAD. But the problem is 3 mil, 3.3, that's, we have 4 mil here. And I already think that this is probably too much. I mean, it's going to use too much filament. So if I want to add a groove here, I would need to increase this to like 5. Even more, because 5 minus 3.3, we're going to be left with 2 point, no, wait. 1.7, yeah, that's less than 2 mils. I think is fine if we make it 5. So we can probably do it. I guess we can do it. So if we save this, FreeCAD, somewhere here. Oh, it's a WebP. Okay, let's go to desktop, FreeCAD, Lure Turner. Where is it? Convert H5 to, let's call it inlet.png or probably JPEG. Okay. How do we import it though? I've never actually imported an image in FreeCAD. Let's see how. Create a new document, change to the image workbench. Okay. So there's an image workbench. Interesting. There is no image workbench. Probably. Probably we need to search for it. Whoops, what happened? I'm confused. I am confused. This is too old though. This one is newer. Interesting. Why don't I have this workbench? Huh. Wait, if I go to here again and search image, interesting, and workbenches. Printing an updated version of my bike swim bait right now uses 83 grams of plastic, including the support. But okay, 83 grams seems too much, no? But or wait, I think your model was bigger, right? Bigger than mine, because mine, I have it here. Wait. Yeah, here it is. That's the size of my bike swim bait. 26 centimeter long with fins. Okay, yeah, that makes sense. But one thing to keep in mind is you don't want too much weight in plastic. You want the majority of the weight to be either like the steel balls or lead. Just post the Blender screenshots in the Discord channel. Let's see. Nice. So you started this. You started this after Friday? That's cool. That's really cool. Yeah, so what I'm talking about, you see your weight holes. You have many weight holes, which is good. But you want to reduce the weight of the plastic as much as you can. You can, for example, now this is a big lure. I think 3 walls is good. You don't need to do 2 walls. 2 walls is for like very tiny lures. But you need to reduce the infill as much as you can. We'll read the rest later. You reworked an old model. Okay, I see. But it's it looks really well. How do you zoom in Discord? I don't think you can. You can only zoom out. I like the fins. The fins look nice. These are replaceable, right? The back fin. It's like it slides up and down. And I see what type of attachment you went for. You went for like two screw eyes and the pen in the middle. I have done this with my chub swim bait. But I try to avoid this as much as I can with 3D printing, because usually there's not much material holding the pen. It will use at least 45 grams of hooks weights and in the belly, then the back. Yeah, replaceable with a dot of glue. Yeah, looks good. Hope it works well. It will probably work even better than mine because of the amount of weight. We'll see. We'll do a pike swim bait competition. Okay, so now let's fight this. FreeCAD image workbench missing. Jacob, hello. I hope both work great. Yeah, I hope that too. So FreeCAD for some reason has a missing workbench. Let's see. Missing image workbench. It seems missing. STD import command imports geometry from a different file. File import. Oh wait, so basically all I have to do is just import. So desktop, FreeCAD. Ah, okay. Okay, so let's rotate it on the y-axis. By 90. I think we can also do transform. Something like that. Oh, that's for rotation. Now, how do we scale this? Change image appearance. I have never used images in FreeCAD. That's the first time. Okay, now it looks centered, but we need to scale it somehow. Fit, draw, measure, no. Okay, let's go back here. Double click works. Image size, okay. Ah, come on. Oh, we can calibrate. Okay, that's it, I think. So we can let's calibrate this, for example, 56. So from here to here should be 56. Is it 0.6? What is this? I'm guessing it's like that. Okay, what happened? This is the inlet. Okay, we're upside down. No. Yeah. So now we can rotate. Come on. This is very trippy. Okay. And now we can move it back. Okay, I guess we can do 0.1 for the increments, so we can have fine control, and this should be it. Yeah, that's it. Okay, cool. So back to our electronic box. I think we have the datum plane here somewhere. Yeah, it's right here. We can create a sketch on it. Okay. And before we do anything here, actually, I want to make this thicker. So let's go with 5 mil instead of 4. Come on. Huh. Now it moved up. Yeah. But that makes sense. Because the thickness from the bottom is... Oh, wait. Let's make this a 1 increment and we can just lift it by 1. Cool. Now we can start doing the sketch. Okay, so it's gonna be a bit tricky, but I'm gonna do half of it and then we can mirror it. So from here to here, something like that. And something like this. We need to fillet this edge and this edge and this edge. Now the problem is how to do that with tolerance also. So we need to, there's a lot of guesswork going. Let's make these equal. Or is there any guesswork? Wait a minute. What info do we have that we can use here? Okay, apparently nothing. Do we have the width at least? Where is the width? I remember we do have the width. This is 24.2, okay. But what is the width from here to here? Oh, I'm guessing it's this. 31. With a tolerance of 0.1, so it's 31.1. Inlet width, inlet height. So now we need a couple of stuff. So we need the inlet outer width. And this is gonna be 31.1. Where's the music? Okay. What about the height? We have the height from here to here, 56. But what about the entire thing? It's 65. So inlet outer height, it's 65. What's with this thing? I don't know what happened there, but okay. 31. So this is gonna be our width. Now the height is a bit tricky to measure because because we don't. How do we measure this? The only way to do so is for either if I know the radius was, but even if I do, okay, I think we can hack this. So if I do a line here, and this line is construction, and then it's tangent to this arc. What is the tangency constraint? Yeah. Now I can measure the distance like that. So this is going to be called the inlet outer height divided by 2. Why did I call it height? I don't know. But basically, now this gonna move yeah. So the circle will always end right here, but we need to somehow we can quickly do that. Let's take this from here to here, make it like that, and then this, for example, okay, yeah, now we don't have to constrain this line. Okay, what else do we need? What I'm gonna do is I'm gonna take a line from this point up till here, and I'm gonna also make this construction geometry. Whoops, where was it? Construction. Yeah, and this will help us with symmetry basically, because I can take this, and this line and make it as a center line. So now this line is always in the center. So we need the height of this, and what do we have? Inlet offset from bottom is 10. 10 is what exactly? Let me see. So if we do electronic box params dot inlet offset from bottom. Oh, we need to add the electronic box params dot thickness. Okay, I got this. So this is where this line starts, but we want this line. So that's a bit more tricky to get, because we need to take the outer width. So minus, we need to take the electronic box params dot outer width, remove from it the inlet width, and then divide it by 2. And now we're exactly here. Okay, what other things can help us figure out these numbers? Interesting. And we can make these two symmetric. And they are also equal, so. Now all of this is without tolerance at the moment. Let me think about this. can't start doing the tolerances before I figure out the values of these radiuses. Perico, hello, how are you? How's the lure making? I guess we just need to guess, so let's see. We have, the problem is that we have two radiuses, and I don't think these are equal. I'm sure they are not. Are they? That's gonna be weird if they are. Let's try. No, you see, that's, oh wait, they are equal. And that's on the outside anyways. Yeah, they are equal. My bad. So I think that's the actual number. 4.3. 4.29. So let's copy that. Insert, oh no. Insert one row below. So this is gonna be called inlet outer radius. And we're gonna set it to this number for now. Oh, come on, where did it go? What was it? 4.29, right? Radius, 4.29, yeah. So this is the electronic box dot inlet outer radius. Cool. Jacob, have to go to bed, have to get up early and go to school early tomorrow. Have a good night, Jacob. Okay, so we got one value left, one value left, which is either the angle here or the distance here, so from this point to this point. And I think if the angle is 45, let me check. Come on. Whoops. No. Don't exit. Is the angle 45? It's the constraint angle. Click this and this line. It's 60. Yeah, that makes sense. I guess I'm just gonna put it here. It looks fine. Kinda. But the issue down here could be because of the calibration of the image. It's not like 100%. But this looks fine to me. Now the only issue is that we don't have any tolerance at the moment. So we will start by, first thing I'm gonna do is remove a tolerance from here. Okay. And then we have this. Let's add tolerance multiplied by 2. Okay. This one will become radius plus tolerance. That's a plus. Okay. 60 remains 60. And I believe we had a width, yeah, right here. So here we need to add also a tolerance. So now it should theoretically it should fit in there. So let's close this. How much do we want to pad it? We want to pad it by the outer thickness. So we need a new row. Inlet outer thickness, and I believe this was 3.3. Let me just make sure. Yeah, 3.3. So here we can pocket, reverse, and the value is inlet outer thickness. Yeah, looks good. Okay. How much left we have here? 1.7 mil. That's, I think, is enough. So now we need to take this and mirror it on the other side. So the inlet should fit in here. And it should be flush with only the switch protruding out. We still have to chamfer these holes. I think I'm gonna do it at the end before I export, because this might be problematic if we have any parametric things going on. So I'm gonna leave it till the end. I think we can delete the inlet, or let's just hide it now. The image. What else? Yeah. Okay. So the power supply is done. The inlet is done. What we need to do is mount the board. So I think I have the board with me. Just give me a moment. It was in one of these boxes. Yeah, this one. So we don't have the measurements online for this, so I have to measure it myself. Oh, come on. Get out. Whoops. Cool. It's a chunky board, but where's my calipers? Okay. So these are 3.34. Let me just be sure. 3.4 in diameter, the holes. And we can use that to get the padding from the edges. 2.75 by... Ah, come on. Different padding on each side. Why? Why? Or the easier option would be to do it this way. So now I'm going from one to the other, and since we already know the diameter, we can do that. So 60.32, I should write that down somewhere. 60.3 by 33.5. 60.3 by 33.5. So 60.3 by 33.5, right? Just to double check. No, it's 60.5. I think I measured it wrong the first time. So this is gonna be the vertical, or let's call it board vertical screw distance, and the board horizontal screw distance. And these should be enough to do the holes. But I'm afraid we're gonna also need spacers for this, or do we? Wait. No, I don't think we need them. Yeah, this is gonna be different than the power supply. The problem with the power supply is it had threads in it, but the screw cannot go in all the way, so that's why we needed these spacers. Now we can still put tiny spacers here, but yeah, I don't think we need them. So I'm thinking if we screw them in from the inside, but we already have screws on the outside, so I'm gonna put it at the outside to stay consistent. So we need 1, 2, 3, 4. Let's do the holes first, and then we'll see if we need spacers or anything. In the electronic box, it's still selected. We need the datum plane somewhere here. Yeah, we have it. Cool. Cool. So we need 4 up here and down there. These are equal. And it is fasteners dot screw diameter plus general dot tolerance multiplied by 2. Nice. Now I'm gonna do something, because we can actually mirror this. But yeah, I don't think we have to. But what we do need is the center point here. So I want to somehow get the center point of this board. And how do we do that? Wait. How did we place the board? Close this. Board placement in the Z axis. Oh, it's in the center of the entire thing. Okay. Okay, and in the X axis, it's what? It's box width divided by 2. Okay, so if I come back here, so the width is gonna be this value, and the height is going to be the general height divided by 2. So it's basically in the center of the entire box. So now that I have this center point, I can take these two, for example, and make them symmetric. So symmetric, and then I can take these two, do the same, symmetric. So now we can, for example, move this, that, but these two should be on the same a horizontal line, and these two should be on the same vertical line. Yeah. So now we have the distance. One thing I forgot to mention, the distances here are from like the edge to the edge, but the distance between the two centers, we need to add, we can do it here. So it will be electronic box params dot board horizontal screw distance. We need to add to it the, what was it called? Wait 1 second. I'm thinking if we need to add tolerance here. Screw diameter. Do we have to add tolerance? I think we do. So plus general dot tolerance multiplied by 2. So now we need the vertical distance. Which is going to be the exact same thing. Board screw vertical distance plus fasteners dot screw diameter plus general dot tolerance multiplied by 2. And now we can pocket. And I think what we need to do here is, well, we can put the thickness, or we can go to first, I think. Yeah, it will not go through the other wall. Yeah, I think that's all in terms of yeah, I think we have everything. So now let's prep it for printing. Let's just bring everything back. Power supply, lure holder. What was the lure holder? Yeah, I'm gonna leave it there. Cool. So for printing, first of all, I'm gonna save, and oh, okay, I see what happened here. I was thinking of using the screws that have the, yeah, no, because I think the screws that I have are countersunk, and I think countersunk are more popular, so I'm gonna use countersunk screws. So we need to fix this here. And to do that, it's in the base plate somewhere. This was what? No. Pocket. No. It's one of the pockets, I think. Yeah, this one. What is this binder? Okay, yeah. Okay, so we need to delete this pad 7 and sketch 15. Okay, cool. Cool. And one thing I'm gonna add in fasteners is, so we shouldn't need these two and these two. Okay, so we have another issue in here. electronic box. Where's the lure holder? Ah, okay, in one of these. Huh. It's in screw 1. So it's right here. So we need to delete that. And what was this? Okay, close it. Delete this. But I need to remember where does the screw go? Oh, okay, yeah, that's easy. So we just need to take this and let me save first. Toggle as active body, and I'm going to chamfer it by 1.6, but I'm not gonna type it, so we need to go to fasteners. Let's call this counter sunk chamfer. Okay, that's funny how I wrote it as 2 words, countersunk. 1.6. So here it's gonna be actually fasteners.countersunk chamfer. Okay, that's one thing done. Where do we have screws? We have in the base plate, right? So toggle active body. And here and here, whoops, we need to do the same. Fasteners, countersunk chamfer. Same here, so an electronic box. Toggle active body, we're gonna go 1, 2, 3, 4, 5, 6. Now we have a small problem here. In this part, will it work? Let's see. Yeah, no. So we need to remove these. For now, we'll see what we can do. But the rest are fine. Okay. And one thing I overlooked is, how are we going to attach this exactly? It's not threaded, right, or something. No, does it have? Where is it? We might need to add a couple of nuts here. I mean two holes for the nuts, so. But it's fine. There's not much stress on this, I think. So there might be no need for the nuts. Any other screws other than these 4? I don't think so. Okay, cool. So let's see. If I take, for example, the electronic box first, or no, let's do them one by one. So motor holder, export. Oh, wait. Let me clean this up real quick. FreeCAD, Lure Turner. We have some step files in here for some reason. I was testing something, I guess. Let's delete those. We don't need this. Cool. So this one first. Motor holder. Save. Okay. Base plate. So Control E is for export. Okay. Save. Okay. Moving platform. Save. Okay. Bearing. No, we don't want to print the bearings. Screw one. Let's just do that. Okay. Screw one. Okay. Screw two. Lure holder. Why not? Electronic box. Save. Power supply. No. Board. No. Motor. No. Screw three. We need it. Base plate pin. We need it. This. Yeah, of course we need it. And the dowel. We also need it. Let's see. I'm guessing this is going to be a very long print. Did I open a new instance? I think it's fine. So we need to import all of these. Okay, let's start by moving things around. Oops. Okay, cool. So I'm gonna start orienting. I think this one will work with auto. This one should work with auto. Also this one. This one should be already fine. Now this one. Yeah, I think we can just print it. This one is tricky because of this. But supports should work. This one is also, let's do auto. No, I think. Is that how I did it? Interesting. Oh, okay. So I'm gonna do a pause to add the bearings. Okay, so these two has to be in their own plate. First of all, let me just select everything and use ABS. Okay, so we don't actually need support for this, but basically before it closes this, I will add a pause. So I will insert the bearing here, and then it will continue printing on top of the bearing. That's the plan. But then this is wrong. How did I... What was I thinking exactly? What will this screw do here? I have no idea what this screw will do. Because the plan is to connect these two together. using this. So we insert a nut from here, and then a screw should go in from here, not from here. Okay, let's hide this. Hide these. Okay, what was I thinking here? So hide the moving platform and hide the bearings. So one of the nuts will enter from here. Okay, so we don't need that chamfer. Yeah, we don't need the chamfer. I think the screw will fit in here from this side. So this way it should work. Let's see. Export as a step, replace. Okay. And then screw 2. Save, replace. Okay. So now we can reload from disk. Okay, cool. What else? The rest of the stuff. Oh, okay. This one also needs a pose. No, it doesn't. So arrange all objects. Allow multiple materials. No, arrange. But wait, where's the plane with the plate with the pause? There's an issue. I can move this probably. Okay, I'm confused. Something is weird. Okay, let's just redo it. That's a pause here. That's a 25-minute print. The reason it's 25-minute, even though these are like very small things, is because of the speed. With ABS, the way it works is they have a minimum layer time of 12 seconds. So if something is super fast, Orca Slicer will slow it down unless you tell it not to, but it's actually a good thing to slow it down. Why does it want to put this in here? Let's see it now. Okay, now we get rid of that error. You see here the speed is a lot more. It's like in the 200s. That's a 6-hour print, which is not bad. These all are fine. All of these are fine. Circle will probably look a bit weird, but that's fine. Okay. We do need support though. I need to enable support, but I'll check it later. Regarding these, I can put this one here, I guess. Why is it so weird with placing stuff on the plate? Okay, that's a 4-hour print, 6-hour print. So it's a full day. I thought it's gonna be worse, to be honest. I thought it's gonna be like a 20-hour print, probably more. Okay, here we have small issues with the speed, but I can probably come here to speeds at the outer wall to 120. Gonna make things a bit better. This one is fine. And wait, how much material was it? 300 grams. Oh, wow. Still, that's nothing. Like, how much is a kilogram? It's about 20 to 25 euros. So that's estimated cost is $9 for the plastic. That's not bad. It's gonna be big. It's gonna be big. But yeah. So I will be printing it in the next couple of days. Again, I'm still waiting for the inlet, but I guess I can start printing it before the inlet. All right. Sorry. And then assemble it later. And I'll keep you guys updated on Discord with pictures and stuff. So yeah. I think that's all for today. We finished early. Please print it in green English carriage color. What do you mean by English carriage? Will be fun to see printed, yeah. Carriage green. I didn't know this was actually a number. Oh, we have the RAL code. RAL. But so one cool thing about RAL codes, I've been using this filament called Spectrum filament. And the reason I use them is because Alza has them, and so I can go fetch them from like next to my house. But if you go here to where to buy now, online shop, I think I'm not sponsored by the way by Spectrum in any way. I don't think their filaments are like the best, but they work. So yeah, we can, I think here somewhere, if you select any one of these, let's say this bank for example, I think somewhere they have the RAL code. No, not general. Where did I see it? Maybe it was on the box itself. But they use these codes. English green, yeah, that's the code, like Parkside Power Tools. Oh, like the Parkside colors, I see. But when it comes to colors, I have this one, wait, but I don't think it's gonna match this green. You see, no, forest. It's called forest green. Now the light from the monitor is gonna make it a bit brighter, but yeah, that's one of the greens I have. The other one, that's actually ABS, but unfortunately I only have 200 grams of that color. Anyways, the thing is, most probably it's gonna be blue, and it's gonna be this blue. this blue right here, I don't know if you're seeing it, because I'm redoing my my painting setup with, what was it called? Multi-board? Yeah. So yeah, I'm gonna print something like this for the wall behind me, where I can hang all my paints and stuff. So everything for lure painting and lure making is gonna be hanged on that wall. And probably I will also hang the lure turner there, this one. And the thing is, I have already purchased black for the color of the, basically it's gonna be similar to this. So black is gonna be the background color, and then this blue is gonna be everything else. So not sorry. Like Parkside. Oh wait, that's an old message. Anyways, I will keep you updated about how it works. It should go smoothly, assuming that all the electronics are working. I should have already tested that, but I didn't. So yeah, hopefully, fingers crossed, by the end of this week it should be done. I really hope that they will deliver the inlet soon, because I will start working in my new job on August 19. It's like my first day of work. But even if I start working, I still have time to do the other stuff. So anyways, I'm just rambling. So yeah, that's gonna be all. So have a great evening or rest of the day, and see you in the next live stream. Bye.